Very creation of the first flying machines, airplanes have been almost exclusively pushed forward and innovated for the sake of military use. One of the main reasons for this being the outbreak of the First World War. Because of just how devastating the First World War proved to be, engineers, designers, and tacticians were trying anything that they possibly could to try and get an edge over their enemies. This included new tactics, new weapons, and new machines. This would ultimately set the stage for what aviation as we know it today would become. Because of how fast airplanes started to be used on the battlefield, the designers didn't really have all that much time to make it proficient at what it was designed to do, being to fly, which led to some really interesting and unique design choices. Aircraft designers were essentially trying to make a useful military asset and a proficient flying machine pretty much simultaneously, because the airplane really hadn't been around long enough for it to get proficient at either. And I figured who better to talk about this than a motorcycle mechanic that flies 172s. So here we are. I'm essentially like if Tom Cruise couldn't fly jets or have a working motorcycle. So before we talk about some of those weird engineering phenomenons and design choices, we have to talk about how we got here. So just a quick brief history of the airplane and the First World War. The Wright brothers fly for the first time in 1903. They've done it. They've achieved what humans have been dreaming of doing for literal thousands of years. And the American public could not care less. According to the Daytona Journal, the Wright brothers' hometown newspaper, their story was, quote, too brief to be noteworthy, and didn't even report on it. Oh, you've overcome gravity and achieved flight like humans have been dreaming and wishing about for literal thousands of years? Big whoop, bicycle boys, we have crop yields to report on. Even the American military wasn't particularly interested, only buying 2 planes from the Wright brothers as an observation vehicle and then putting them in a museum only 2 years later. Europeans, however, were more receptive to the airplane and really began implementing it and trying to refine it. And this is really where you would see the art of airplane designing, and the European nations were really the first ones to get particularly good at it. Europeans actually kind of have a habit of taking American ideas and taking them to the extreme, like being insufferable. In case you've been living under a rock, there's a quick summary of World War I. We have the Archduke Franz Ferdinand gets assassinated by a teenager. The entire world is upset by this. Millions suffer and die. We blame all of this on Germany. Overall, this is considered a pretty cool move, and anybody who knows anything about history knows that this would have absolutely no consequences whatsoever. Maybe I'll do a video on some of the weird planes that came into the Second World War. Up first, we have the Sopwith Camel. This was one of the most common fighters used in the First World War, and it suffered from a particularly strange phenomenon because of its engine design. The Sopwith Camel had what's called a radial engine, where the pistons are arranged in a circle. On modern radial engines, the engine block stays stationary while the crankshaft attached to the propeller rotates inside of the engine block. Early radial engines didn't use this design. They would have the engine attached to the propeller, which would rotate around a stationary crankshaft, essentially spinning the motor attached to the propeller at the same speed. The problem with this design is that early airplanes were extremely light. They were made of mostly wood and canvas, with really most of its mass taking up the front of the plane where the engine sat. If you take a giant hunk of metal like an engine block and spin it to a couple thousand revolutions per minute, you've essentially created a ginormous gyroscope on the front of your plane. Gyroscopes suffer from something called gyroscopic precession, where any force applied to a spinning object is felt 90 degrees in the direction of rotation. This made it particularly dangerous for new pilots low to the ground, because if you're turning your aircraft to the right, a bunch of forces and aerodynamical factors are happening, but essentially you're placing pressure and force on the right side of the gyroscope. This pressure and force is felt 90 degrees in the direction of rotation, pulling the aircraft down. This made it particularly dangerous for new pilots who weren't prepared for how much force would be applied when they're turning to the right, especially low to the ground, especially after takeoff, and often resulted in stalls and crashes low to the ground where you couldn't recover fast enough. The gyroscopic forces were so intense that common doctrine for pilots who flew this plane, instead of turning 90 degrees to the left, would make a full 270-degree turn to the right to change course, because it was so much faster than simply turning to the left and trying to fight all the rotating mass that was associated. Some pilots praised the Camel for its maneuverability, but it was so difficult to handle that it almost had the same amount of deaths resulting from combat as it did from training missions. Up next, we have one of the most dangerous and prevalent issues that faced early aviators in particular, that being V-speeds. Now, V-speeds in the modern context are speeds that are used for safe operations to do specific things. Like VR is used for rotation speed. VY is your best climb over a specific distance. And one of the most important, I think, VA, or maneuvering speed. Maneuvering speed is the speed that if you are below the speed, you can put full input on one of the controls and it will stall before it damages something. That's particularly important for like fighters and other aircraft that are pulling high G maneuvers and putting a lot of stress on the airframe. As long as you're below that speed, you can pull as much as you want and it will stall before you damage something. Early aircraft, they didn't particularly understand how this works. The structural integrity of airplanes during the First World War was not particularly great. That's why you see so many airplanes that are either biplanes or triplanes, because the airplanes are pretty much made out of that you can get from a Joanne store and hand assembled using the best techniques that you know how. Trying to add more wings was the only way they could really get any more support out of the airframes that they were using. And there was multiple instances of pilots in a dogfight, say you got somebody in their homemade flying apparatus behind you trying to kill you. So you nose over and point the nose down to get some airspeed and get away from them. Pulling up from this maneuver puts a lot of stress on the aircraft, and oftentimes this could shear the wings completely off. It's incredibly dangerous. Pilots were trained. This was something to be aware of, and you need to ease your way out of particularly aggressive maneuvers. So I guess they would kind of just pull back until they heard expensive noises. The next thing I wanted to talk about was the early design of fighters and how they came to be and just how dangerous they were. Early in the First World War, airplanes were almost exclusively used for observation. Pilots considered themselves masters of the sky, and even if they were to observe an enemy pilot, they would simply salute as they flew past, believing them to be both masters of the sky. And honestly, I can't particularly blame them, because the stories I've heard about these flying homemade death traps is enough to garner respect from even your enemies. Eventually, pilots realized that having another enemy near you observing your troop movements and what you were doing was not great, and decided to start doing something about it. The first air-to-air kill ever recorded was by a Russian man named Pyotr Nestorov, who upon observing an Austrian observation plane decided to just ram it and killed them both.
But I come here for everybody! Kill everybody!
Eventually, pilots started carrying things like bricks, flechettes, and even grappling hooks trying to damage enemy observation planes. Some even started carrying rifles trying to shoot down other planes as they flew past. And that all changed when Roland Garros, a Frenchman, put a gun directly in front of the cockpit in his line of sight, shooting through the propeller, creating essentially the very first modern fighter as we know it today. And you might ask yourself, wouldn't bullets shooting through a propeller damage the very susceptible to bullets wooden propeller? Yes it would. And Garrus's solution to this was to straight up just put a metal plate on the back of the propeller. The idea being that it could take a couple bullets before it completely broke and disengaged. While very primitive, this was probably the best option for a direct line of sight fighter at the time. Some airplanes utilized pusher configurations, which were most often two-seater and were very slow compared to the single-seater fighters. Some utilized something called Foster mounting, or mounting the gun on top of the wing, which was difficult to fire accurately and even more difficult to reload. But nothing could quite compete with Garrus's design. Eventually, Roland Garros was shot down, and an Austrian airplane designer named Anthony Fokker would find Garrus's design and, believing that he could make a better version, created what was called the disruptor gear. The disruptor gear would stop the machine gun from firing while the engine was in a configuration where the propeller would be in the line of sight of the gun. This proved incredibly effective and created something called the Fokker Scourge, where the Austrian airplanes were so effective against the Allied forces that they had no way of competing. While this was probably the best option at the time for shooting through your propeller and having direct line of sight to your target, these two also had an incredibly high risk of failure, and oftentimes the mechanical gears would fail, especially high RPMs, and the pilot would shoot its own propeller off. It's kind of crazy to me that some French guy in like 1916 was like, hey, what if we put a gun on a plane? And then some coke addict in the 70s was like, hey, what if we put a plane on a gun? Then we have this monstrosity. Anyways, that should about do it. The more I learn about early aviation, the more I am glad that I exist when parachutes are pretty standard and mathematicians and engineers exist.